All right, so the third bullet point said we're going to look at how to evaluate a logarithm, and we're going to do this by hand, even though technically not all logarithms can be evaluated by hand. It's sort of like evaluating a square root. And we are still online for the foreseeable future, so we really don't need this skill, but still worth chatting about in case we ever end up in a situation where we're back on campus. So we can look at a very simple example. We're going to say, let's go ahead and evaluate, which means find the value of, and we'll evaluate something like log base 3 of 9. So we have two ways to do that. We can either rewrite this as an exponential because those are just easier for our brain to handle. We'd go ahead and say, well, we don't know what this is. But if I rewrote this as an exponential, this is 3 to the we don't know what it is equal to 9. And we'd be like, oh, okay, obviously the we don't know what it is 2. We can also do what they say here as number 2. We can use previous knowledge to say what exponent should 3 be raised to in order to get 9. So if we replaced all that stuff, what order should 3 be raised to in order to get 9? And we'd get back to 2. This is the same thing I did here with 16 to what power is y. Same idea. Obviously, we can do more challenging problems as well, and we saw even those more challenging questions in the Kahoot, right? We could have something like evaluate log base 3 of 1 over 27, or evaluate log base, no, ooh, I like this one, 8 of 4. Ooh, that's cute. That's cute. All right, so both of these are much more challenging because even if I rewrite them, it's not as obvious, right? If I use that same idea, like what power of 3 gives me 1 over 27? Or if I rewrite this in the exponential form, 3 to what is equal to 1 over 27? Or 8 to what exponent is going to give me 4? And so this requires us to do a lot more thinking, right? To think about what's going on. So we can, if we're clever about this, um, we have some ways that we could handle this. Finally, I can write the 4. If we have something in the denominator, that means there must have been a reciprocal, right? We must have done a negative exponent to get this thing into the denominator. So for this one in particular, we need a negative so that we can bring the 3 down to the bottom. And then that's the third power. So log base 3 of 1 over 27 is just negative 3. That's our solution here. 8 to 4, though, 8 to what power to give me 4? That doesn't work as well. We know that it's half of 8 is 4, but that's not a power, that's a multiply. So we might have to think about what 8 and 4 have in common, right? 8 is 2 to the third power, and 4 is 2 squared. So if I could make 8 into 2, this would be a much simpler problem. In fact, maybe it would be easier if we started with log base 8 of 2, right? Well, I know that 2 is the cube root of 8, so this would be 1/3. So we're just saying, okay, well, instead of 2, though, I want this thing to be 4. So what power do I need to raise 8 to in order to get 4? And a mistake here would be to think that the 2, that power is also going to be applied to the 1/3. But in reality, what happens when you multiply, when you take an exponent and do another exponent, you multiply. So that's exactly what's going to happen here. And this is where we get one of these exponent rules we're going to see later, that the power can be rewritten as a coefficient out in front. But this makes sense. If you actually go in and write out the math here, and this is something that my calc students struggle with, is if I give them something like 8 to the 2/3, a lot of them, what they will do is they'll square 8 first, right? Because this can be rewritten two different ways. This can be written as the cube root of 8, and then the square can either happen inside, or it can be the cube root of 8 with the square on the outside. And it's always, 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 if the root works, if you can take the radical, always better to do the radical first so you don't make your numbers humongous for no reason. So in this case, we're saying the cube root of 8, which is 2, squared, which is 4. So this, not the easiest thing to do in your head, but it is something we could do when they have that kind of common base going on in terms of the exponential. And we can get there with exponent rules later, or we can kind of reason through it, thinking about what we would need to do to manipulate that 8. So that's evaluating a logarithm. It really doesn't get any more exciting than that. And I'll do one more video to introduce the common log and the natural log, and we'll be done with 4.3.